Hello friends, I always talk about technology and I always talk about the safety, and I am on a mission to make my India free of accidents, free of failure. And when I talk about the failure of equipment, it has a direct impact on my tariff, outages and everything. And in the present era, we are relying on only GIS because we don't have space available to go with the AIS right now. And when you are working with AIS, you need more space. With GIS, that space requirements becomes 25%, and the only challenge with GIS is to pinpoint the fault, especially after doing the PD, partial discharge. And we have many equipments with us, and we have very technology available with us. Earlier we were working with acoustic, presently we have shift to UHF, ultra high frequency. And ultra high frequency we depends on the PRPD patterns and PRPS pattern to analyze, to pinpoint the fault within my GIS. I am very lucky. I am with Sudhanshu Gupta ji, who is the basically author of GIS Manual of CBIP, that is the Bible book in India. And I'm very lucky he's with me, and we are going to talk about. He has come out with a new thing, that is the time of flight technology, and that enable user to pinpoint the fault within a GIC with a minimum time, and that enable them to reduce the outages and the cost involved in pinpointing the fault and removal of that fault within the GIS. Sudhanshu ji, welcome, and kindly throw some light on the technology time of flight, how it is different from PRPD and PRPS that is already available in the market.
Thank you, Auradi, for providing me opportunity to discuss on this latest technology. Actually, it's not different from the PRPS and PRPD. Uh, anyway, our equipment is also providing PRPD and PRPS also. It's one step ahead.
Okay.
Like with the time of flight measurement, which is a built-in feature in our equipment, you can isolate noise.
Okay.
Because if I have a time of flight feature, then I can put many different algorithms like time of arrival to reject noise, and to pinpoint the fault I can do the time of flight measurement. Time of flight is like wherever you have a fault between two sensors,
Okay.
I should be able to locate.
Okay.
Otherwise, I will not be able to maintain my GIS properly, because in between two sensors there can be a distance of 5 meters, 10 meters, depending upon the GIS configuration, and you will have many compartments in between. So if you don't have this facility, time of flight, you will have to open up everything, and then you have to locate it. Now I wanted to bring to your kind attention that sometimes people try to say that like time of flight is not necessary because they can pinpoint by using acoustic PD.
Okay.
So here I wanted to clarify, like acoustic PD is okay where you have a free particle kind of issue or a floating component, but for insulation defects, acoustic PD is almost blind.
Okay.
Which I already mentioned in my like CBIP book, because that portion was covered by me. I have mentioned very clearly in CBIP manual that acoustic PD cannot detect insulation defects.
Okay.
So, if you have an insulation defect, and if you see the statistics of a GIS failure, almost 40% failures are due to the insulation defects.
Great.
So in that case, your equipment will be like you have to rely on a technology where you can locate by using time of flight.
And my question is, you are talking about the time of flight, but the success rate of that technology you have that time.
Okay, like time of flight is almost having a 100% success rate.
Great.
And almost like I am saying, when you come to the pinpointing it can pinpoint the location within an accuracy of 3 to 5 centimeter, because you have cables and other stuff and some. So you have to learn how to bring the.
What are the special precautions to be taken when you are going to use that time of flight?
Cable length should be calibrated.
Okay. In the absence of that, there will be some error.
100%.
Okay. There should not be kind of loop or anything. That should be properly.
That should be properly accurate cables, and my suggestion is it should be within 0.1 nanosecond.
Any special type of cable required for that time of line?
Yeah, it should be of low loss cables, and I think cables should be RG, at least RG216 type of cable.
Okay.
And usually I use a low loss cable which is slightly expensive, but when you go for a time of flight measurement, the cable cost is nothing.
Okay.
So I would say the main thing is you have to calibrate the cables also. So cable length should be calibrated, and the accuracy of the cable length, that like time difference, should not be more than 0.1 nanosecond.
Is there any software required to pinpoint the fault, or it automatically give with the help of algorithm?
Yeah. Actually, in our equipment, that's the SDMP UK make PD71. It is having a built-in feature for time of flight. Like when you measure like your normal measurement, it keeps on capturing the raw data, and it stores it. And based on that raw data, it does the time of flight measurement, and it will give you the results. So it's very easy to use, and perfect example for maintaining. And most important part, it can tell you whether the PD is coming from the outside GIS or from inside GIS.
Okay.
That is the most important parameter of time of flight.
Can I use that technology for my transformer also?
Yes, 100%.
Okay.
And
any success story you have for transformer?
many. I'll share some case studies. Actually, not from India. It's from outside India, but it is there are definite case studies are there.
In India, have you done any?
I'm going to do one time of flight based PD measurement very soon.
Okay.
And I will share you the results.
Thank you.
And that will be the landmark in India, because it's the first time in India we are going to do that.
Great. And friends, we have learned new things. That is the time of flight measurement method for PD. And I hope that technology will go a long way and can protect many of equipments in India. With that, thank you, sir. Thank you very much.
Thank you, sir. Thank you very much. Thank you.